So, hi everyone, my name is Dmitry and I'm CTO at MixBytes. And today I'm going to present my experimental framework regarding how you should write tests to catch some severe bugs. Before we start, let me share a bit about MixBytes. So we're mostly focusing on conducting security audits and research. We have been working since 2017, and since that time we worked with more than 60 clients and performed more than 250 audits. Most of our clients are coming back to us with new protocol versions and small updates in their code base. So the list of our key customers are presented here. So now back to the topic. The general recommendation for writing tests is often unclear. For example, preparing 100% test coverage is not save you from severe bugs. Also, a general recommendation for using a hacker mindset while writing the test is very hard to adopt if you are not a white hat hacker or experienced security researcher. So today we'll discuss the question presented here. And the first one is, will 100% code coverage prevent hacks? And the answer is, of course, not. The second question is, what exactly is a hacker mindset? And the third one is there any other type of mindset that will help writing tests? And the last one, how should writing tests be approached to identify as many issues as possible before an audit? Before we go into the next slide, how many of you heard about a hacker mindset? Please raise your hand. And how many of you know how to apply to this recommendation? Okay, it's nice. So the framework, it's our experimental work, and I went through a lot of different security audit reports and bugs that happened in our industry, and came up with an idea that actually, while you're writing the tests, you should use 3 mindsets to cover all possible severe bugs. And the first mindset is a hacker mindset, and we will discuss it in detail later. The second mindset is a formal verification mindset, or it also can be named as an invariant mindset. And the last mindset is a system architect mindset. So applying all these 3 mindsets should help you write very thoughtful tests. In our company, we promote an approach for writing tests, which is follows. Not for writing tests, for audit. The audit is a process of generating questions regarding the code and answering them. This approach is much easier to explain to new security researchers and Web3 developers. With this approach, it's much easier for you to control the progress of your audit, and it's extremely helpful with the code bases, which are well written and huge code bases, around 8,000 lines of code. So I think that's it. That's why it's easier to explain this framework as a set of questions for each mindset. The answers for these questions should help you write good tests that will help you identify bugs. So to use this framework, you should select one of the mindset, one after another, get the questions from this mindset, ask them yourself, and the answers will help you generate the test scenarios that will help identify bugs. So the first mindset that I want to discuss is a well-known hacker mindset, and the general idea of this mindset is to force yourself to think about your code not as a developer who developed all the use cases for users, but as a malicious user who is trying to find a way to interact with your protocol to break it. So instead of asking how it's supposed to work, you should ask yourself how it's not supposed to work. And that's it. Well, no. The questions for this mindset are follows. what use cases exist for the protocol that should not be accessible to regular users. And this question should be asked for all the public and external functions that you have in the protocol to identify which of them should be called only by some special roles or special services, and write tests that check that this function can be called only by a verified role. For example, here we can come up with a test that checks that the function can be called only by a off-chain service that should update some parameters. The second question is what limitations are there on the sequence and frequency of function calls by users. And this question should help you identify all the reentrancy attacks, and it should help you to restrict the user flows with which users can interact with your protocol. So you have to restrict all possible use cases that you designed before, and all other questions should be restricted for all users, and it should cause rewards. So here, an example of a test. For example, you have a function that should be called only once per an hour, and if it's called more frequently, then you have to restrict this, and it can be done by adding a require, and proper test should be written for that. The third question is what constraints should be placed on user input parameters. And this question is about restricting your protocol even more. So the general idea actually of a hacker mindset is to restrict your protocol as much as possible. And this third question is about restricting input parameters, and here we could think about a function that accepts unsigned int 256 and converts it inside the function to unsigned int 128. And if you not restrict the maximum value of input parameter, then your protocol will be probably hacked. And the last question is which parameters cannot be controlled by users when calling the protocol. And this question is about identifying which parameters shouldn't be controlled by users and should be controlled by some whitelist or by some constants that only admin or privileged role can update. So the next mindset is a formal verification mindset, and this mindset cannot be merged with a hacker mindset, because here you should ask yourself about not how your protocol shouldn't work, but you should think about how your protocol should work according to the specification. And for these purposes, you have to write specification. It's a very hard task. Nobody likes to do it, but you have to. And the specification will help you a lot with this mindset, because you will know what to expect from your protocol, and you need to write tests that checks that it works according to the specification. And so yeah, it's identifying invariants from the specification and implementing special tests like fuzzing tests or going through formal verification to check that your protocol works according to it. And here are some examples of the invariants. The first one, in a function that calculates the number of tokens to be output during a swap, it must be guaranteed that the number of tokens output cannot exceed the contract balance. This invariant is very helpful for new version of Uniswap v4, when only one contract contains all the tokens, but there are a lot of contracts that could interact with this contract, and if they somehow trying to transfer more than they can, then most probably the protocol will not work as expected. And the second invariant is a variable that stores the total amount of tokens that the protocol control is less than or equal to the balance of that token for the contract address. This invariant is real good for lending protocols or just regular vaults that accept some deposits from users and stores them in special variable, and you should check that this variable is like the value of this variable is equal to the actual token balance for this contract. The last mindset that I want to discuss is the system architect mindset. And this mindset is about thinking about all the protocol integrations in a very paranoid way. So like all the external integration could fail at some point. Like an Oracle service can stop updating the price because it reached some threshold value. And this happened with Luna, I think, when the price goes like really fast. An off-chain service could have a bug in a new update, which leads it to misinterpret milliseconds as seconds, which can affect your protocol. External DeFi protocol can update its logic and distributes more rewards to your protocol, and this reward should be claimed to a special function that you didn't add because you didn't know that you should. And the cross-chain breach can just fail to transfer your message to another chain because you failed to set correct gas amount or there was an internal error in the breach. So here it's only one main question that you should ask yourself. It's which of the protocol dependencies are external and could fail. And it's very easy to answer this question. You should just go through all the integrations that you have and mark them. And after that, you should think about like in which way it could fail your protocol, like what can happen with this integration. And I think it's crucial to prepare mocks for all off-chain services that will communicate with the contract to check cases of how the protocol will react on a failure in the off-chain service. And another question here is which of the integrated protocols are upgradable. And here you should just think about upgradability feature of the integrated protocols. And if you integrate with such protocol, it's better to make your contract upgradable also. So in conclusion, I want to emphasize that test preparation is a very important thing. And like developing a Web3 protocol without thoughtful test preparation is dangerous. 100% test coverage is not like very good recommendation, but it should be done. You should have at least from 80 to 90% test coverage, and you should cover all unit and integration tests. So you should be ensured that your protocol works as you expected. And after that, you should apply these frameworks that we discussed today to ensure that all severe bugs are covered with the tests. So while you're using this framework, it also can be beneficial for you to prepare a checklist of the test scenarios. So when you will be developing a new version of your protocol, you could use this checklist to prepare tests that you prepared for the first version. And also, all mindsets are crucial, and it's important to cover your code with all the mindsets. And like you can skip the system architect mindset if you do not have any external integration, but I cannot like remember any protocol that I audited in a year or two that didn't have any external integrations. And yeah, write tests, stay safe. Thanks for your attention. I would be happy to answer your questions. Yeah, we have some time, I think.
Hello? Okay.
Thanks. Thanks for the talk. Usually, when trying to find interaction, like sequences of interaction that lead the system in a broken state, like writing a state machine diagram works pretty well. Do you have any tips or any automated tools to do that kind of stuff?
Could you repeat the first part of the question? It was
so it's the idea of like drawing a state diagram to try to lead the system in a broken state. Do you have any tips or automated tools to do that kind of stuff?
I don't know regarding the automation tools here. Like most of them are not very good right now. But yeah, like writing a state machine for a protocol, it's a very nice thing to determine like in which states it could be and just like restrict the states that you want your protocol to be. So yeah, it's a very nice thing to do. More questions?
I have a question about different kind of test. Which parts should be covered of the business logic? My point is, you have mentioned about unit test, integration test, even those kind of formal verification test. I say that a kind of test. So, according to our own business, for example, lending protocol, which part of the specific test should cover which kind of, different test method or kind of patterns? Do you have ideas or recommendations for the protocol builders? How to decide and how to consider that is we can satisfy all the logics we can cover?
You mean like for which functions each mindset should be applied, or?
Yeah. You are talking about the coverage. I consider that was a unit test coverage.
Yeah.
All the code of the branch.
Just like basic testing to ensure that your protocol just works.
Yes. How about formal verification? What kind of integration test or formal verification should cover about the business or the basic code base?
So unit test and integration test, like general test coverage, it should help you to be sure that your protocol just works. And all the mindsets that I discussed, it helps you to ensure that you have additional layer of security on top of just like basic use cases. So you have to write basic tests, and after that you have to switch to the mindsets and cover like with a hacker mindset, cover with a formal verification mindset, and with a system architect mindset.
And how about fuzzy testing? Fuzzing,
yeah, it's like actually it's about the same as the formal verification, but there is a small difference that formal verification gives you 100% sure that the invariant holds for all the states of the protocol, and fuzzing tests only some specific cases. So formal verification is better, but if you don't have like time or budget for this, you can use fuzzing tests.
Okay, thank you.